Tesla built something that brought an entire industry to a complete standstill. Not a concept car, not a prototype gathering dust in some lab. An actual motor inside an actual vehicle you can walk into a dealership and purchase right now. And the strangest part is not the motor itself. It is the silence. The biggest automakers on the planet. Companies that have been doing this for 100 years. Companies with armies of engineers and research budgets rivaling the economies of small nations have gone completely still. No counter-announcements, no competing reveals, no bold promises about what is arriving next quarter. Their own engineers looked over the designs, ran the numbers, examined every single component, and then they stopped talking. When the most experienced people in the entire industry study a piece of technology and choose silence over response, something serious is going on. This is that story. The engineer who went quiet. There is an engineer by the name of Sandeep Ralph. He has spent years doing one specific thing, studying electric drive systems at a professional level. Not as a hobbyist, not as a journalist, but as someone who genuinely understands the physics, the materials, and the mathematics behind how electric motors actually function. When Tesla's new motor specifications started circulating, he did exactly what any engineer would do. He sat down, pulled up the document, and began reading. And then he stopped, not because the numbers were unclear, but because the numbers were impossible. Not impossible in any theoretical sense. Impossible in the sense that they described a motor you could lift with your bare hands, light enough for a single person to carry, capable of launching a 2-ton car from 0 to 60 miles per hour in under 2 seconds. That level of performance is simply not supposed to exist in a vehicle with a backseat and cup holders. That kind of output belongs to machines built for one purpose only. Track cars, industrial equipment, not something parked in an ordinary commuter's driveway. And yet, there it was. To understand the war that was already unfolding, you need a bit of context. For more than a decade, the electric vehicle race had been one of the most expensive battles in the entire history of transportation. Ford, General Motors, Toyota, Volkswagen, companies that had planted factories on every continent, that had mastered manufacturing across generations, that carried more resources inside a single division than the entire auto industries of most countries. And standing beside them, Tesla looked fragile. Exciting, certainly. Ambitious, absolutely. But fragile. The conventional wisdom said it was only a matter of time before the giants fully mobilized, threw their full weight behind it, and closed the distance. So they moved. Billions flooded into electric vehicle programs practically overnight. New factories climbed up across Europe and Asia. Engineers were recruited, retrained, and repositioned. Every few months, another new company emerged, each claiming it had finally cracked the formula to beat Tesla at its own game. And for a stretch of time, it genuinely appeared to be working. Batteries got better. Designs grew sharper. Charging networks stretched further. The competition was real. The gap was closing. Then Tesla unveiled its new motor, and the gap did not simply stop closing. It reversed. What followed genuinely confused everyone paying attention. The rivals said nothing. There were no press conferences, no engineers stepping up to promise something superior by the following year, no sweeping roadmaps rolled out at trade shows, just quiet. The particular kind of quiet that settles over a room the moment everyone realizes the game has already changed and nobody thought to warn them. Sandeep Ralph was not the only one who fell silent. Across the entire industry, the people who actually understand motors, the ones whose job it is to evaluate these systems professionally, looked at what Tesla had produced and landed on the same conclusion. Tesla had not simply moved to the front of the race. It had left the track entirely. Consider Sandy Munro. Munro built his entire reputation by tearing cars apart and telling people straight up what was wrong with them. He is the kind of analyst who hunts down problems for the sheer pleasure of it. Someone who approaches every product with professional skepticism and decades of hard-earned experience. Someone who is almost never genuinely impressed. When Munro and his crew dug into Tesla's drive technology, the expected criticism never arrived. Something stranger happened instead. Respect showed up, wrapped in a kind of unease. The tear-down specialists, The people whose entire purpose is to find the flaw were having trouble locating one. And the most unsettling part for every competitor watching was not simply that the motor was brilliant. It was that the motor was nearly impossible to copy. By certain estimates, rebuilding this technology from the ground up could take years, possibly close to a decade. And by the time any rival managed to catch up, Tesla would already be somewhere completely different. So how did a company that everybody expected to fall behind end up this far out in front? To understand that, you need to know exactly where Tesla stood in the moment before this motor appeared. Because it was not winning, it was bleeding, the sales struggle. The Cybertruck was meant to redefine absolutely everything. When Elon Musk rolled that stainless steel wedge out onto the stage, the reaction was immediate and enormous. The shape was unlike anything the truck market had ever laid eyes on. The angles were sharp enough to feel pulled straight from science fiction. Millions of people watched. Investors celebrated. The narrative practically wrote itself. Tesla was about to swallow the entire pickup segment whole. That is not what actually happened. Sales landed far below projections. The vehicle that was supposed to ignite mass demand instead became evidence of a harder truth, that spectacle and actual sales are not the same thing at all. The Cybertruck turned heads absolutely everywhere it went. It just did not fill order books the way its dramatic reveal had suggested it would. Then came something even more uncomfortable. Analysts examining registration data noticed something unusual. A meaningful portion of early Cybertruck registrations appeared connected to companies inside Musk's own orbit, SpaceX, XAI, and other ventures tied to the same broader ecosystem. Some estimates suggested roughly 1 in 5 trucks registered during a key quarter may have gone to Musk-linked organizations rather than independent buyers. Subtract those numbers, and the picture looked considerably weaker. But the Cybertruck's struggles were really just a surface symptom of something running much deeper. Tesla had launched into a world where it stood nearly alone. That world no longer existed. Every major automaker now had electric vehicles out on the road. Competition had multiplied, prices had dropped, standing out had become genuinely difficult. Recalls and quality complaints piled on more pressure. Public confidence softened. The press started writing a very particular kind of story. This is the moment when most companies pull back. They trim their ambitions, protect their margins, and wait around for easier conditions to arrive. Tesla did exactly the opposite. Which brings us to the question worth sitting with for a moment. Why would a company operating under that kind of pressure choose its biggest, riskiest technical gamble at precisely this moment? The answer to that question is what drives everything that came next. Defying physics. There is one harsh truth that governs everything inside electric vehicle engineering. Physics does not negotiate. For years, every automaker on the planet believed they were trapped inside a fundamental trade-off. A car could be fast and powerful, or it could be efficient and travel serious range on a single charge. Achieving both at the same time seemed to violate something basic about how energy actually behaves. Build for performance, and the motor ran hot, wasted energy, and required massive cooling infrastructure just to keep functioning. Build for efficiency, and the driving experience suffered for it. Everybody accepted this as fact. It was not considered a design choice, it was treated as a hard physical boundary, and for most of the industry, that ceiling had been treated as something permanent. A boundary you engineered beneath, not through. Tesla chose to go looking for a different kind of limit altogether. Its engineers poured years into the problem, not months, years. Iteration after iteration, dead end chasing, dead end. And the solution they eventually landed on sounds almost anticlimactic once you actually hear it. Wrap the rotor in carbon fiber. Here is why that detail matters so much. Inside every electric motor sits a spinning component called the rotor. At elevated speeds, the forces bearing down on that rotor become enormous. Centrifugal pressure builds along the outer edges, working to tear the whole structure apart from within. Engineers describe it as a constant war. Push the rotor too hard, and the material deforms, weakens, gives out. That mechanical sealing, invisible, unannounced, quietly shaped every motor decision every automaker ever made. Nobody punched through the limit. Everyone built their machines inside it. For decades, the ceiling was so widely accepted that it stopped registering as a limit at all. It just felt like physics, like gravity itself. Tesla wrapped the rotor in carbon fiber. The material is extraordinarily strong and remarkably light. The wrap squeezes inward, holding the rotor together against the forces trying to tear it apart at extreme velocity. The concept is elegant. The execution is brutal in its complexity. Carbon fiber and copper expand at different rates as they heat up, which means winding the material at precisely the right tension required machinery that simply did not exist yet. Tesla had to build the machine that builds the motor entirely from scratch. What they ended up with was a motor capable of spinning at more than 20,000 revolutions per minute. 20,000. That is territory belonging to specialized industrial equipment, not a sedan someone parks in a suburban driveway and uses to collect their kids from school. But the raw speed was not even the real revelation. The revelation was what the carbon fiber wrap did to absolutely everything else. At those extreme rotational speeds, the rotor stayed stable, balanced, under control. That stability sharpened the motor's magnetic performance, which meant more electrical energy converted into actual forward motion rather than bleeding off as heat. Massive instant torque, breathtaking acceleration, still efficient over a long highway stretch, compact, light, demanding less cooling than competing designs. Performance specialists had flatly called this exact combination impossible in a vehicle intended for everyday use. The Tesla Model S Plaid proved every one of them wrong, 0 to 60 miles per hour in under 2 seconds, a figure that embarrassed exotic hypercars carrying price tags of millions of dollars. And then it hauled a family hundreds of miles in that same afternoon. Picture an automotive journalist with 20 years spent testing every car that matters. Someone who walks into every press launch already half bored, who has heard every bold claim before and knows precisely how most of them end. Who already has the skeptical review half drafted in their head before they even settle into the seat. Put that person in a Plaid. Let them press the accelerator a single time and watch what crosses their face. It happened again and again. Reviewers grasping for language and coming up short. Engineers at rival companies watching the footage in complete silence. Because a specification printed on paper can always be argued with. A four-door family sedan humiliating $1 million supercar in a straight line is not an argument. It is a demonstration. It simply happened. And once something happens, you cannot make it unhappen. For decades, the industry held on to a certainty. Choose speed or choose range. Pick one, live with the compromise. Tesla chose both. That is the moment the competition lost its voice. You cannot call a press conference to undo a physics demonstration. You cannot announce your way around it. But here is what you need to understand going forward. The motor was only the part the public could actually see. The real reason competitors fell into a panic runs a level deeper than most people realize. And it has almost nothing to do with how fast the car goes. Here's why nobody can simply copy what Tesla has done. Every major industry has players capable of producing a breathtaking prototype. The pattern is well worn. A concept vehicle shows up. It looks absolutely jaw-dropping. Headlines pile on. Investors start moving money. The story being told is that everything is about to change. Then actual production kicks in, and that bold vision crashes headfirst into reality, and most of the promise quietly vanishes somewhere between the engineering lab and the factory floor. The distance between what a company can sketch out and what it can reliably manufacture at volume for a price that actually makes financial sense. That gap has swallowed up companies with genuinely brilliant engineers and enormous resources. Building one outstanding car is genuinely difficult. Building 1 million of them consistently, profitably, at scale, that is a completely different animal, and it is precisely where most companies tend to quietly fall apart. Tesla figured this out earlier than the rest of the industry was willing to acknowledge. While rivals were fixated on big reveal events and polished marketing moments, Tesla spent years grinding through ugly, unglamorous manufacturing challenges that nobody was eager to publicize. The company itself called it production hell. Missed timelines, brutal inefficiencies, literal tents thrown up outside facilities just to squeeze out extra capacity. The kind of operational misery that makes for awful press coverage, but builds extraordinary knowledge inside an organization. Those painful years are now paying dividends in ways the broader industry simply cannot afford to ignore. Tesla disclosed that its next-generation drive units are being engineered with manufacturability treated as a primary design constraint. Not just raw speed, not just efficiency, the actual ability to build the thing at scale cheaply, without costs ballooning as volume increases. That single idea, treating the factory itself as a core part of the product, completely reshapes the boundaries of what becomes possible. The target Tesla put on the table hit the industry like something physical. A complete drive system, motor, electronics, gearbox for somewhere around $1,000 to manufacture. Many competing systems cost several times that figure. Some manufacturers are spending 3 to 5 times as much to achieve comparable performance. That gap is not a minor difference. No procurement negotiation closes it. No process adjustment or supplier swap gets you anywhere near it. It reflects a fundamentally different philosophy about how you build the thing from the very beginning. A competitor cannot bargain their way into Tesla's cost structure. They have to completely rebuild how they approach the problem from scratch. Imagine the cost analyst sitting inside a legacy automaker, someone whose entire career has been dedicated to finding savings, trimming margins, squeezing small efficiencies out of complicated supply chains. That person has spent their professional life battling for incremental victories. $1 saved in one place, $2 trimmed somewhere else. That person's entire toolkit becomes useless when the competitor is not just slightly cheaper. When the competitor is running at a fraction of your cost, the spreadsheet offers you nothing. The boardroom conversation has no satisfying answers because copying a motor is hard enough on its own. Copying a motor that is simultaneously far cheaper to produce while still matching its performance. That is an entirely different problem altogether. A rival could take apart Tesla's rotor and measure every single dimension with precision. They could map out exactly how it functions, and they would still be completely unable to replicate what actually matters most, because the genuine breakthrough does not live inside the component. It lives inside thousands of decisions that are invisible from the outside. How the part is manufactured, how it is sourced, how the tooling was conceived, how the process was refined across years of iteration and failure. None of that shows up in a tear down. It lives within the institutional knowledge of a company that earned it through slow, difficult experience. That kind of knowledge cannot be bought. It cannot be hired away. It can only be accumulated the hard way, over time. And Tesla has already paid that price. And Tesla keeps pushing into new territory. The company is working to remove rare earth materials from its motors entirely, reducing reliance on costly supply chains that are heavily concentrated in China. That is not purely a cost-cutting decision. It is a strategic one, eliminating a weakness that every single competitor also shares. At the same time, the company is reworking its electronics to use cheaper silicon carbide without giving up efficiency. Each improvement pays for the next one. Lower manufacturing costs allow for lower pricing. Lower pricing attracts more customers. More customers mean higher production volumes. Higher volumes generate greater manufacturing experience. That experience brings costs down even further. The loop keeps accelerating. Meanwhile, the rest of the field is struggling in ways nobody expected at this point in the game. Ford produced genuinely impressive electric vehicles and reportedly bled enormous sums through its EV division. Lucid built extraordinary luxury machines and burned through capital at a frightening pace. Rivian grabbed massive public attention and then struggled to rein in production costs. General Motors and Volkswagen ran into delays, software catastrophes, and persistent doubts about whether electric vehicles could ever turn a real profit at all. Only BYD operates at a remotely comparable scale. But BYD's core strength is affordability, not technological leadership. Tesla is chasing something fundamentally different: the most technically advanced electric vehicles on the planet. built at the lowest achievable cost. That combination, top performance and genuine economy delivered simultaneously, is the real threat here, and nobody else is anywhere near it. Most people still think of Tesla as a car company. That may be the single biggest misunderstanding in this entire story. Tesla has merged several industries into one self-reinforcing machine. Start with data. Every Tesla out on the road is continuously collecting information. Every mile driven teaches the company more about road conditions, driver habits, weather events, traffic patterns, and the unpredictable real-world situations that push self-driving systems in ways a controlled test environment simply never can. Tesla has gathered more real-world driving data than nearly any competitor in existence. And that advantage builds on itself automatically. More vehicles produce more data sharpens the artificial intelligence, better artificial intelligence sells more cars produce more data. The cycle never stops, and the variety of that data matters just as much as the sheer volume of it. A Tesla in Norway gathers knowledge about ice and poor visibility. A Tesla in Arizona learns about heat distortion and blinding sunlight. A Tesla in Mumbai learns about traffic that operates by rules no engineering team ever formally sat down and documented. Every unusual intersection, every construction anomaly, every near collision gets absorbed into the system. No rival can recreate that by running test fleets in controlled environments. The entire point is that it is not controlled at all. It is the infinite, messy, unpredictable real world, recorded continuously across more than a decade. This kind of lead cannot simply be purchased. No supplier sells it, no budget unlocks it. It can only be earned through time and scale. A competitor starting today is not merely behind. They are falling further behind with every passing day because Tesla's fleet keeps expanding while theirs is still being assembled. Then there is the battery side of the operation. Tesla invested heavily in manufacturing its own cells because the battery is the single most expensive component in any electric vehicle. Its 4680 cells are engineered to push energy density upward and production costs downward at the same time. Most competitors remain dependent on outside suppliers for this. Tesla increasingly commands its own supply chain. The company also designs its own software, its own chips, and its own power electronics in-house. When a global semiconductor shortage paralyzed much of the broader auto industry, Tesla adapted faster than almost anyone else by rewriting its software to run on whatever hardware was actually available. That single episode exposed what Tesla truly is. It operates the way a technology company does, one that also happens to make vehicles, and its factories reflect that same philosophy. Fremont, Shanghai, Berlin, Austin. A worldwide manufacturing network that keeps expanding, with new facilities already in the works that could drive costs down further while unlocking vast new markets. Most automakers think of a factory as a building where vehicles get put together. Tesla thinks of every factory as a testing ground for figuring out how to build cars better than the last factory managed to. Then there is the weapon nearly everyone failed to take seriously, the supercharger network. For years, critics wrote off Tesla's charging infrastructure as a convenience perk, a pleasant extra, nothing with real strategic weight. They were mistaken. The supercharger network turned into one of Tesla's most lasting advantages because it is quick, dependable, geographically widespread, and straightforward to use. Competing charging networks became notorious for broken equipment, confusing payment systems, and unreliable connections. So eventually, the competition did something that would have felt unimaginable just a few years before. Ford and General Motors adopted Tesla's charging standard so that their own customers could tap into Tesla's infrastructure. Century-old industrial giants with their own engineers and their own technical standards looked at the charging problem, looked at their own networks, looked at Tesla's, and decided the smartest thing to do was simply join the other team. The rest of the industry followed, one by one. Think carefully about what that actually means. Tesla's rivals now rely on Tesla's infrastructure to keep their own customers happy. Tesla collects revenue every single time a competitor's vehicle plugs into a Tesla charger. That is not competition in any traditional sense. That is one company quietly becoming the foundation everybody else builds on. This is why the new motor unsettled people so profoundly. It did not show up on its own. It arrived as part of all of this. The more closely you look at Tesla, the more difficult it becomes to call it a car company at all. On the surface, it manufactures electric vehicles. Underneath, it is assembling something far bigger. A technology company built around energy, software, data, and artificial intelligence, using vehicles as the entry point. Consider Dojo, Tesla's custom-built supercomputer designed specifically to train AI systems on the enormous stream of driving footage pouring in from its global fleet. Rather than renting general-purpose computing power from cloud providers, Tesla is constructing much of its own computing backbone. The reasoning is straightforward. Tesla believes its future depends less on the cars it is selling today and far more on the intelligence those cars will carry tomorrow. This produces another self-reinforcing cycle. Better vehicle technology moves more cars. More cars generate more driving data. More data speeds up AI training. Smarter AI strengthens autonomous capability. Better autonomy raises the value of every vehicle across the entire fleet. Higher value supports stronger margins. Those margins fund better hardware and deeper research. The cycle nourishes itself and keeps building momentum. The uncomfortable reality for every competitor is this: a cycle that is already spinning cannot simply be copied. By the time a rival reaches the point where Tesla stands today, Tesla will have spent that same stretch of time moving somewhere entirely new. The gap does not wait while you chase it. It grows wider. This is precisely what those rival engineers understood in the moment they fell silent. They were not staring at a motor they could not replicate. They were staring at proof of a process they could not replicate. Talent can be recruited away. Parts can be reverse engineered. A rival can even outspend you for a year or two. What no one can do is reach inside another company and pull out the compounding loop of data, manufacturing knowledge, and artificial intelligence that took well over a decade to develop. There is simply no shortcut to any of that. There is only the long road, and that road keeps stretching further. The electric vehicle race has stopped being simply about building cars. Tesla is competing across every single layer at once: battery technology, software, manufacturing, artificial intelligence, real-world driving data, charging infrastructure, and global production scale. Catching Tesla on any one of those fronts alone would demand years of dedicated effort from any rival. Catching it across all of them simultaneously, while Tesla itself never stops moving, that is an entirely different challenge altogether, and that is the true reason the industry fell quiet. It was never about a single engine. It was the moment competitors realized that the engine was merely evidence. Evidence of a machine they have no way of replicating. A machine that keeps generating breakthroughs faster than anyone can fully absorb the previous one. The carbon fiber rotor is not the actual threat. What created the carbon fiber rotor, that is, the threat. The electric vehicle revolution is absolutely real. It just does not look the way most people pictured it would. Rather than an open marketplace filled with balanced competition and equal footing, what is emerging is a world shaped by one company that moves faster, learns more quickly, and has constructed a deeply interconnected system that everyone else is still circling around, searching for its edge. So go ahead and tell us what you think. Has Tesla already pulled so far ahead that catching it is impossible? Or do you believe rivals still have a genuine path forward? Leave your honest takedown in the comments. We read every single one. And if this changed the way you see what Tesla truly is, do us a favor. Hit like and subscribe, because the next chapter of this story is already being written.